So we'll go ahead and get started.
Don't let them get to you.
I am Ryan Linn. I am a senior security consultant at TrustWave, and this is Mike Ryan.
Yep. I'm a lead security researcher for Startup Research Team.
So this is why we're here. We're going to talk about man in the middle for a little bit. We're going to talk first about how man in the middle works. We're going to talk about some effective scenarios with a couple awesome sort of demos. And then we're going to talk about what's missing and how to fill the gap. Thank you. I was hoping. You can't throw stuff like that out there and just not respond. So this is interactive, so when that happens, you guys come on. So before you came into my life, really layer 2 attacks have been around for a long time. The problem is that a lot of pen test companies are scared of them. And the reason is they have sort of a bad rap because people go and just blast packets out and hope for the best. So they're not being used really effectively. So when they are used appropriately, it is full of win. So really a couple things that we're going to talk about is how most people are using it, which right now what you see all of the awesome demos online about is how to sniff passwords, which is just like this little teeny piece of what man in the middle can do. But it really is about so much more. So what we're going to be talking about today is we're going to be talking about first a couple of the scenarios that typically people are using man in the middle for pen tests. We're going to talk very beginning about what it is and give a little scenario for how somebody would use it. We're going to go through can enable. We're going to look a little bit at EtherCap, and then we're going to look at some work that we've done to try to make it more usable for everybody and try to take this to the next level. So we're going to tell a story first about meeting a girl, and this is going to be a love story because everybody loves a love story, and this is going to be a love story about a John, a pen test John. So first the boy becomes a man in the middle, and the boy installs Backtrack 5 and follows this pretty girl into a coffee shop and uses EtherCap, a man-in-the-middle tool that is able to inject traffic into an HTTP stream. And so he injects a nice little page when she visits YouTube, and her only option is yes. So John now has a date. So now we're going to look at how the boy becomes the man in the middle. So first we have 3 devices. We have our pretty girl on the bottom left, we've got John on the bottom right, and we've got our router in the middle. And you see that each one has a MAC address. So we're going to simplify this for the purpose of this conversation, and we're going to say that the router has a MAC address of MAC GW, and our lovely lady has a MAC address of MAC A, and the loving John has a MAC address of MAC B. So first what happens is the girl has a MAC matching the gateways for her IP address 10.0.0.1. So when she tries to go there, what really happens is your local network traffic isn't gone to by IP address, it's gone to by MAC address. So her machine resolves the 10.0.0.1 to the MAC address for the gateway, and the gateway says, okay, that machine matches the MAC address for her machine. So her machine is 10.0.0.100. So when they communicate and she goes out to Facebook, she sends a packet destined for the gateway with the IP address of facebook.com. So what John does to steal her traffic is he asks who has her MAC address, but then also puts out an additional packet that says, tell me I am 10.0.0.1 at John's IP address. So now she has in her ARP cache that her gateway is John's IP address. Well, so now when she requests Facebook, she goes to John, which is always a horrible idea, just for the record. But what John does is he needs to make sure that the traffic comes back through him so that he can see both parts of the conversation. So he goes ahead and sends out another advertisement that says that he is also the MAC address for her machine. And so the MAC address for her machine gets cached in the router as being John. So here's what happens now. When she makes a request to Facebook, that request goes to John. John forwards it to the gateway, so he's seen the request. And then when the request comes back, he sees that as well. Okay, so now what though? You have the ability to see both sides of traffic. So here's where we inject traffic into the stream. And as you know from Ghostbusters, you always have to be careful when you're injecting traffic into the stream. So when we're talking about UNC path injection, what we're really talking about is we're talking about taking the conversation and adding something to it, so that instead of just going to where somebody intends to go, they're also coming to our site in some way. So you can redirect them to another site to steal cookies, to gather additional information, and we're going to look at one of these scenarios here in a couple minutes. Or you can just be a creep and just watch everything that's going on. So with this scenario, you can sit and watch somebody almost indefinitely to be able to see all of the traffic that they're sending and receiving that's unencrypted. So with EtherCap, you have another feature, which is the SSL downgrade attack that's recently been added, where you can actually go ahead and give them a fake SSL certificate and see some of their SSL traffic too if they click OK. And it turns out that everybody clicks OK. So, that really makes this very powerful. But what EtherCap really is we're talking about, this is a tool that takes advantage of a layer 2 configuration weakness, which layer 2 is the Ethernet layer. It lets you actually deal with the MAC address of the packets going back and forth and seeing that traffic. So we're not talking about TCP or IP or any of that at this point. But what EtherCap lets us do is it actually surfaces those to us so we can actually take advantage of the layer 2 manipulation to be able to deal with level 3 and 4 traffic, to take advantage of information about sessions and also, for instance, reroute traffic through us for other stuff. So why does this still work? And the big reason is that, first of all, people have a hard time understanding like what this really means. Being able to do a man in the middle if you're already on somebody's local network doesn't always sound like a big deal, but really you have to be able to convey this in a way that people really understand it. And really a lot of systems have the ability to remediate this, but they don't understand the infrastructure and they don't understand the hardware they have. So the other reason is that, again, this is considered to be an insider threat, and of course there's, you don't have to worry about insider threat because we trust all of our employees because everybody's an angel. But girls need to get to Facebook eventually, and it turns out that just about everybody will eventually click yes. So in the real world, the way that we use this is it's a great way to pivot once access is obtained. So once we have access to your local network, this is how we gather credentials. This is how we gather additional information in order to get to other assets on the network. So proof is hard to come by because of this, because it isn't permanent. When we start manipulating ARP tables, unless somebody is actively watching the ARP tables on the network, nobody is going to see that we've changed it, and it's not going to be obvious that we've captured the traffic. And when we undo the ARP spoofing, there won't be any evidence that we've done it to begin with. So how do you even know when this has happened to you? And so we use this a whole lot in pen tests. It's great for getting recon data about what hosts are talking to other hosts. And also, UNC injection has been around for a long time, where you inject a link into a stream so that you can get somebody to come to you. So we're going to talk for a second about basic middling. Kah and Adrian has been around for a long time, and there's tons of videos on it. It's a Windows-based tool for sniffing and man-in-the-middling traffic. It has password crackers built in, and it's basically a all-in-one tool for if you want to do some basic cred stealing on the network. You can click 2 hosts, get everything you need, and traffic will start coming in. Where I also use it is when I'm using EtherCap and I'm capturing traffic as I'm doing man-in-the-middle, it'll parse them for credentials. So let's take a look at one of these for a second. This should be the only demo that I have that isn't going to be live because I've got one too many VMs up already. But so let's take a look at this. To start off with, we have a couple different tabs up top. We've got the sniffer tab, and what we're going to do first is we're going to enable promiscuous mode on the NIC. Promiscuous mode, oh yeah. So then we want to scan the network in order to find all the other hosts. Basically what this is doing here is this is sending out broadcast packets to map MAC addresses with IP addresses. And so once we've done that, we have the ability to set up a poison route or an ARP spoofing scenario. We do that by going to the ARP tab and clicking the gateway that we want and the target that we want, which is in this case 192.168.50.51. Once we do that, we click the radiation sign, which is ARP poisoning. And so once we've radiated the network or poisoned it or whatever, we can go to the password tab. And here is where the credentials come pouring in. And so in this case, we have a host that you can't see on the screen that's requesting HTTP traffic. So this is kind of weird though, right? Because here you see that the username is demo1 and the password is blank, but it turns out that there's actually a password there. So what we're gonna do with this is we're gonna send this to the cracker, and we highlight the demo1 user, and we right click it, as soon as we turn off promiscuous mode apparently, and we're gonna send this to the cracker, and because everybody loves a cracker. And so here we can see that the user is demo1 and the domain is spiders. We see two things here. We see an NTLM v2 hash and a server challenge and a client challenge. So for everybody that knows, NTLM v1 has a single challenge. It is set by the server. So whenever you control the server, that is more vulnerable because you have the ability to set a static challenge, which then you can use rainbow tables and some other techniques on. So when you actually are using NTLM v2, you have two challenges. You have a client challenge and a server challenge. So this is the harder one to crack. We're using a dictionary attack here. And so what we're going to do is we're going to reset our word lists to the beginning, and then we are going to send it to the cracker. But luckily, this user used an awesome password, password1. So, okay, so just to be serious for a second, this password is all over the place. What are people thinking? So one of the things that we do on Pentest frequently is we just guess, when we're able to enumerate domains, is just guess password1, and it turns out that a crap ton of people use it. So I have no idea what's wrong with people. But, so now we have this, and this is just the basics for how to use Kane to capture credentials. As you can see, there's a ton of other crap over here on the left that it can crack, and there's a couple of other things that it can sniff. One of the interesting things is, while this was running, IMAP was actually running in the background. And so it never actually got the IMAP credentials that were going back and forth. And the reason is it wasn't on 143, it was on a different port. So one of the limitations that a lot of these tools have is they're looking for specific protocols on specific ports. So we're going to address that later, so remember that. So we can do better than this, right? Let's talk about EtherCap. So EtherCap is a feature-rich man-in-the-middle framework. It has EtherFilter for allowing us to manipulate traffic en route, which is what we use the UNC injection for, and it's recently been picked up by some new maintainers, as well as they've added some SSL middling and some other great stuff that helps make it more useful. So EtherFilter lets us create some basic filters to do things. They're compiled before it's run, and it has some limited abilities. Some of the things that it does very well are replacing. So here's an example of a basic replacement script. We can see that if something is on TCP in port 80, then we're going to replace the end of the head tag by a script that will load a script from us. So let's take a look at this one real quick. So for here, what we want to do is we're going to look at our script. So for our script, we have a couple of things. The first thing is how many people here are familiar with accept encoding field? So accept encoding field, what it does is it says, okay, these are the types of things that I will accept. gzip and there's one other that I can't remember, deflate or the other one, that are really common. And what they do is they compress the data to save on bandwidth. The problem is if we can't see that data, that really sucks. So what we'll do is we'll replace accept encoding by accept nanopus, because the browser doesn't really know what a nanopus is. I'm not sure that I do either, but at least we're all on the same page. So then what we want to do with everything in the clear is we're going to look for TCP packets that have port 80, and when we see the body tag, we're going to add in our script tag. And so that's going to allow us to do some fun stuff. So one of the things that we can do with this is we can leverage this to bring people to one of our capture servers to capture credentials. So let's see if we can make this work. So right now I already have the NTLM capture stuff running. So we have it running with the URL path of /gather. So what I'm going to do is I'm going to edit this and come down here and change this to gather. And now we need to turn this filter into something that EtherCap can understand.
Oh, sorry.
Seeing how bad my typos are. We're doing it live. It'll be awesome. As long as we don't phasal it too bad, it'll be perfect. So next we need to compile this into a filter. So we're going to use eder filter. Oh yeah, I can spell, seriously. So now we're going to turn this into the EF file, and we're going to specify our filter file. So now basically what this has done is compiled it into bytecode that EtherCap can understand. So next, I'm going to steal from the command lines this right here. So what we have here is we're going to run EtherCap in ARP spoofing mode on ETH1. Q means don't print out the contents of every packet you see. T says we're going to use text mode, and F is the filter we're going to use, which is the inject filter. We're going to create a session between the gateway, which is 192.168.50.1, and this client here. So we're going to go ahead and run this, and we are going to watch here as well for packets coming in, and then we're going to find our awesome Windows machine. So this is a fully patched Windows 7 box with all the latest patches and Windows Defender running. So we're going to go to our intranet site and hope that this works. So, and it's cached our previous version. So what we can see here, and we'll reload this a couple more times, I think. Okay, so we can see here that it's downgrading the encoding from all the requests. And we can see here now that the string that we have included in has caused them to come to us and give us credentials that we can now crack. Now, one of the things that you'll notice is that because we're on the intranet, I've created this little broken image to show that it actually succeeded. But typically when we do this, we embed it so it doesn't show anything to the client, and the client never knows that we've injected anything into their browser. We have their password to crack offline, and so far in doing this, I have not been caught. So here's the trick to this, just for the record. Don't poison a whole subnet. If you're on a class B and you try this, someone will come and hunt you down and kick your ass. I'm not lying. So, you know, target hosts that you think are going to be interesting and look at those. And Eric's actually going to be doing a talk later this weekend. He's going to be talking about how to do this smart, and I think that that is something that everybody needs to know. So don't poison the whole subnet. Remember, I said so, somebody will kick your ass. And pick the things that are going to be most meaningful. So this is just a basic use of eder filter to inject something. So we're going to talk some more about how this can be improved in a little bit. So I'm going to pass this over to Mike.
Well, I guess I don't need the microphone. I'll wander. So the work that we've done was inspired by, well, our motivation really was simply that you can't really do a whole lot with something like eder filter, or even gain enable. I'm sorry, you can do a lot with them. You can't always do what you want to do, which might be involve going above and beyond. So what we're gonna look at some of the limitations that exist in the tools today, and I'm also gonna talk about some of the stuff that we're working on to make them better. So if we look at Kah and Enable, the first things that we think of is, it's closed source. There's no way for me or Ryan to really contribute to it. It's also Windows only, so the flexibility really isn't there for you to, if you happen to pop a box that's on it's like a Unix box on the network, you're not going to be able to run Kah and Enable on it necessarily. In the mode as that Ryan demonstrated, you really can only gather credentials with it. But at the end of the day, sometimes we look at a tool like that and we say, yeah, it's really great, but I want to be able to modify traffic or capture things that are flying by that we don't necessarily see, kind of like the IMAP stuff that Ryan was talking about. So we switch over to EtherCap. It's open source, that's really great. It's got filters and plugins. Filters, you can craft on your own. Plugins, if you know C, you can write those. It's already got built into it several protocol dissectors that if you can write C, you can take advantage of them. It's also got IP, IPv6, and TCP session tracking built into it, which is really convenient. The problem, as I see it and Ryan sees it, is that filters are stateless. So if you put together a filter like Ryan did, where you're looking for stuff flying over the wire on port 80, it's kind of an all or nothing deal. You're jamming stuff into every single HTTP request and response that's going across the wire. Sometimes you want to be able to maintain state between several requests. So you want to inject attack A on request 1, attack B on request 2, attack C on request 3. We want to make sure that, well, if you inject all of them at the same time, you're going to have bad time. So it leaves you can run into limitations with the filter. It's pretty quick. And like I said, if you really want to take advantage of a lot of the really neat stuff that's built into EtherCap, you have to write C, and not all packet heads are also really comfortable with C. So, like I said, I already said this slide. Presentation. Okay. It's my first time, everybody. Thank you. Thank you. Thank you. That's right. Thank you. I got a laser pointer. Gonna make me use it. All right. All right. So we thought to ourselves, gee, that's a pretty high barrier, to overcome if you really want to do cool stuff with packets. We wanted to really make something that's accessible to the masses. I think there's a lot of really, really smart people out there who want to do really, really cool things, have really rad ideas about things that they can do with protocols and packets and everything like that, but they're not coders, so you can't necessarily expect all those things to come to fruition. So going with the scripting language, we figured that we could put something together that would be very approachable. Scripting languages tend to let you do a lot of things, or something in a lot of different ways, and have it work, whereas C, you kind of got to get it to work right the first time. So some of the more popular scripting languages that are out there, Python, Lua, and Ruby, all of them are embeddable to some degree, but which one should we go with? Python, it's very, very common, it's been around forever. There's lots of libraries, there's a lot of security work going on with it, so if we did embed it inside EtherCap, you'd be able to turn that stuff around and use it right away. Promise, I don't know much about Python. I'm sorry, I'm that guy. I don't think it's very fun, white space, as a dilemma. I don't know. I tried, I spent 15 minutes on it, no dice. Lua, no, it's not as fully featured as something like Python. No, it doesn't necessarily have a lot of libraries to back it up and make it sound really interesting and spicy and all that. There's some documentation on it when you search about Lua. For trying to get answers with Lua, you find a lot of people talking about video games, World of Warcraft, probably a bunch of other crap you guys played. It's in mod security, so it's in a lot of security tools. I don't know if you guys know mod security. I don't know how many of you knew that Lua is embedded in it. It's easy to embed. It was really designed to be embedded into C applications. It's got a very low profile on it, so you really can hit the ground running. It's 2 lines of code, and you've got a Lua interpreter running. And it's also used in a lot of other security tools. So, like I said, mod security, also Nmap. There's also Ruby for the Metasploit fans in the room. I myself love Ruby. I probably spent 2 days trying to embed Ruby in EtherCap. I do not think it was designed with the intention to be embedded in anything at all. They only want to run in the main thread. They don't like being shoved off into other threads. I think that's weird. But man, wouldn't it be cool if you could directly hook Metasploit or Beef into EtherCap? I mean, you'd be able to do some really rad things. But as soon as you get it actually running and embedded and stuff, it gets kind of big. It's got a VM that's pretty clunky, but once doing the right thing, it goes fast. So I tried as hard as I could. I mean, my original intent was trying to embed every single scripting language I could. To be like, hey guys, here's obvious, have fun. But I wasn't making any progress. So of these, if I haven't dropped any hints so far, which one do we use? Really? Oh my gosh.
No way.
Why? Because performance is important. You're moving packets over the wire, and if you move them slow, people are going to go, hey, what's going on with my computer? My internet's is broken. It's easy to provide new functionality in Lua. I mean, if you're ever, I don't know how many of you guys are coders, it doesn't matter. It's easier to wrap a C function or a call to a C function in Lua than it probably is in the other language that I've messed around with. What we really want to do is, try to make the end product easy to use. If you have to know, like Python, it's just off the list because I don't want to have support email. People have, hey man, my script isn't running. Well, you got to make sure you don't have enough spacing in here. But at the end of the day, I really want people to be able to focus on the task. And that's, you want to twiddle packets. You don't want to have war stories about debugging scripts and everything. That's just crazy. That's not progress. So, Lua. Like I said, it's got very little overhead, and I'm going to show you some of the choices that we made, which I think are the right ones. It's actually really, really fast. It's easy to mess around with, and really, it's a matter of, okay, now, yeah, we put Lua in it, but, is it a good idea? I mean, we still have an opportunity to screw it up. So we want to make the interface easy and maybe even familiar to people so they don't have to, concern themselves with brand new terminology. We want to make it very modular so that when people are writing their actual scripts, we don't have to reinvent the wheel or anything like that. If people got great ideas, we want to roll that in and get it out to the peoples. Also being able to call scripts in the command line, pass arguments, that's all exciting and everything. So, as for inspiration, it seemed pretty natural to look at something like Nmap, the Nmap scripting engine. Anybody ever run Nmap? Of course you have. I mean, everybody runs NSEs, and that's the thing to do with Nmap. Any people here write NSEs before? Yeah, we got a few. Yeah, Matt Conda, right there. Stand up, Matt. Everybody. All right. He drove all the way from Chicago. He doesn't have to stand up. Matt, please don't stand up. I don't want, no, he's very ugly. I don't want people to, I don't want him to get self-conscious. So, Nmap. So I already got, I think that started in 2006, they embedded Lua in it. It started as, I think, a Google Summer of Code thing. They tend to have a very simple interface for writing scripts. Obviously, you can get complex, but damn, there's a bunch of libraries for it already. The core API for starting from scratch is actually pretty simple. You've only got a few rules that you have to implement. Like, I want to look at these ports, and then you got an action. I'm going to do this stuff whenever that happens. The NSC lib is pretty expansive. It's pretty impressive. One of the things I'm really impressed with, documentation. They put all that stuff online, so if you're ever in a pinch, you can find out everything you need to do in order to get rolling on a pen test. One of the other things that I think is really important is they seem to have a really big focus on the community. That, they didn't design something that's there to only be updated by the developers of Nmap. I don't think that that's a successful model. And look at something like Metasquare. It's all about user contribution. If you look on the credits page for Nmap, there's like 100 names on there of all these different people that decided to throw stuff into it. I think that's really fantastic. And when you're on a pen test, you're going, oh man, I got to put something together that I can maybe use the next time, and you do. And then people like sharing that stuff, so they like bragging about things. I don't know. But really what I'm trying to say, let's be honest. But I mean, really at the end of the day, I really think if you look back through the history of many of the security projects out there, Nmap's doing it right. It's really successful. That stuff took off. So the interface, well, I'll talk about how we did it a little bit. So we began with EtherCap's EtherCap RC branch, which it's the release candidate. I don't know when it's going to be released, but yeah, okay, cool, man, awesome. All right, well, our stuff's not really ready for your stuff today, but that's cool. So soon to be the master release, great. But it's the big conversion there was, as I saw, was changing the build system to CMake. I'm a developer. That was like heaven because it made it not suck for me to have to do what I had to do. Lua, it's got, like I said, a really simple implementation. There's actually several different implementations out there. There's Lua, which is the only thing that the core project. There's LuaJIT, which is Lua with just-in-time compilation. It's actually really amazing. It's a really well engineered product. But the big thing with it is it's Lua 5.1 compatible, so we can expect Lua scripts that you develop and most other things to probably work in this as well. It's also got insane performance, and that's what the focus of this project was so that they could perform nearly as fast as C code. So once it goes through the initial just-in-time compilation, you're cruising along really fast. So even if you do write some massive, disgusting script in Lua, and we do, and we're going to show you demos in a little bit, where we're not really going to show you the code because it's ugly, but it's pretty fast. It's I was freaking out. I thought that I was going to knock the performance in half, but some of the things I was doing, I was like, here's 3%. Cool, all right. I didn't do things wrong. One of the techniques that we used in order to move things along quickly was take advantage of Lua's FFI interface. If you're not a developer, that's a magic word or a magic little acronym, stands for Foreign Function Interface. It makes it easy to dynamically interface with C libraries. So instead of having to write a bunch of C code in order to take advantage of stuff that already exists inside EtherCap, I can use FFI to quickly map Lua functions into the EtherCap's main process. What this means is it takes me it's like 5 times faster for me to do this than it is to go, oh man, I'm going to try and remember some C and look at and deal with compilation errors. And usually it just barbs at me and I go, okay, I'll tweak something and it works. I don't write a lot of C. What? Yeah, that's right. But I don't write a lot of C. I mean, it was an easy way for me to move things along and then just kind of defer doing the harder stuff until later. So I can, yeah, my sex life on the stage. So I feel pretty good right now. So really at the end of the day, we can write some ugly stuff and then move to really efficient C implementations that we feel really confident in the future. So the implementation that we put so far, I mean, where it differs from Nmap NSC, where there's a focus on hosts and sockets and generally working at layers higher than layer 2. We're working at layer 2. So we're working with packets. That means a lot of things, but you can generally expect that you're going to be dealing with things on a packet by packet basis in there. We don't have fancy stuff like TCP stream reassembly. It's not NetterCap right now. That's kind of a pain in the butt if you want to actually implement it. It's a lot of you have to emulate a whole stack of things, but there's stuff that we can take advantage of that makes it work out all right for us. The scripting interface is similar enough to EtterCap or to NSC that you'll be able to take advantage of knowledge you already have. There's packet rule, which basically lets you say, hey, I only care about packets that look like this, and then in action it's like, I'm going to do this crap to a packet. They've got IP and TCP session tracking inside EtterCap. We've implemented a lot of that as of yesterday. Yeah, yesterday. So this means that we can do stateful tracking of packets, or at least a session, as the packets are going by. If you've ever done any stuff with packets, none of that stuff happens automatically for you. Yeah, I think that we're going to have a demo pretty soon that's going to kind of demonstrate exactly that. So,
go do that now? All right, let's do some demos. Yeah. All right, wake back up. Everything's going to be awesome now.
Wake back up. Thanks a lot.
That's what he said.
Yeah. No, he said, I'm just going to go in the other room and browse the internet.
Now that we've talked about my sex life on stage, so if we remember, we were talking about IMAP a minute ago and how sad I was that Kah and Adrian didn't pick up my awesome session. So what we're going to do is we're going to look at a Lua filter that will help make this better for us. So we're going to kill this EtterCap session. So first, let's go ahead and look at the filter. So for this, we've sort of organized it kind of like Nmaps is. So for this, we've installed this into ops EtterCap. And so in the share, let me make sure that this is big enough we can see it. That's what she said. So once we look in the share directory, we see that there's a Lua subdirectory. And in here, all of our actual scripts, just like for NSE, you have the scripts in the NSE directory, all of our stuff is going to be in the scripts directory. So from here, we're going to look at the get IMAP demo, because this is the IMAP demo. So first, we have the basic description, just to say what it is. We're including a couple of the libraries we've written to make this easier. So for the first thing we have the hook point, and the hook point is where this injects into the C code, and this doesn't matter for you right now. All that you need to know is that hook filter means we actually get the whole packet right now, and that is awesome. So we need two things. We need a packet rule that says when the hell this thing's supposed to fire. So it gets passed in a packet object. So we care about two things. First of all, is it TCP? Because if it's not TCP, then it's certainly not IMAP. So first thing, if it's not TCP, then we get the hell out of here. Second thing, we want to figure out what the port is that it's going to, because in this case, for this demo, we're looking at something that's going on port 1143. So it turns out that Lua doesn't have like a whole lot of network manipulation functions, which is one of the things that sucks. So we included a function in your function. And we use the FFI to actually get us the NTOHS for anybody that programs in C. That basically makes it from the network version of what the number is to the number that we actually care about. So we're using that function to get the desk port. One of the things that we're working on doing with this is making these functions easier so that you could like run a function called like get network port and it would return this, and then you don't have to care about any of the C stuff. So we're still in the process of abstracting some of this. So basically, if this is port 1143, then we're good to go. But if it's not, then again, we need to get out of here. So the only time that this will return true is when this is going to a server on port 1143, which is the IMAP port that we're using. So it turns out that when it is, we get passed this action function. And the action function is where all of our actual work happens. This is where we can manipulate packets. This is where we can do some additional parsing. And this will give us all of the information about the packet itself. So the first thing we want to do is we want to get the data portion of the packet, because what we're looking for is, all we care about for this is the username and password. So this is just really simple. So if the command, the string match, has a login in it, then that is awesome. But it turns out that people use login in other frameworks or in other contexts during conversation, so we need a little bit more than that. But if there's no word login in there anywhere, then we know that we're completely done. So the next thing we do is we try to match the username and password in a login string format. So this is sort of like a regex. Here the %S is something that's not a space. So we're looking for a command that is login, and then in quotes a username, and in quotes a password. And then if that works, then we got the IMAP user that we're looking for. So let's look at how to run this. So the way that we run this is we take the same command as before, and we're going to try this. And again, hopefully I don't phasel it too bad, but we're going to do Lua script equals, and then we're going to look at our get_imap_demo. Okay, so that looks mostly right. So we'll give that a shot. Oh. Oh, it turns out that I actually have 2 editor caps installed. So let's try to run the right one. Oh yeah, because that'd be awesome. Oh, also the new one has more slashes because it supports IPv6. So you gotta add your slashes. So don't forget your slashes, kids. So anyway, so we're poisoning now, which is awesome. So the next thing we need to do is hope this doesn't crash. When I run Thunderbird, it won't crash, seriously, it'll be awesome. Okay, got IMAP user test 1, password 1. So we have now gotten the username and password off the wire using Lua.
The reverse phasal.
Now here's the part that you all may not appreciate is, at least for me, C is hard. So this got it easy. So that is the true beauty of this, is that it is pretty easy. So the next thing that we're going to talk about is, and Mike referenced it earlier, you know what sucks? Only being able to inject one thing. And here's why. Because sometimes I want to both steal credentials, hook a web browser with beef, and browser autopwn somebody. Don't browser autopwn people all the time, because then they'll notice that something's wrong and they'll be like, what the hell? And then you'll be caught. But anyway, this is an example. So what we want to do is, if you run all of those at the same time, you won't get any of them, because browser autopwn will DOS your browser. So what we need to do is we need to have it so that as somebody's browsing, first, we're able to steal their credentials. Second, they get hooked with beef, and if you look at the Schenk presentation we did at Black Hat, you can see how to auto-run a bunch of modules at beef to profile users. And then third, we want to try to pwn these people with browser autopwn. Again, careful with your pwning. So, I'm not going to show you the code for this next one, because I'll be honest, it is a whole lot of C stuff mixed in, but we're gonna make all that easier. So one of the things that we need help with, just for the record, is there's a whole lot of more things to put together. So people that are interested in making this more awesome, we're gonna just come up later, and we'd love to talk to you, because it turns out we have other stuff to do besides code, unfortunately. So
Heather should just stop Ryan from working so much before we have our talk, so we can get this stuff done, and not today.
So the next one we're going to do is, yeah, I don't remember what this one's called either. So we look in our scripts directory, and I'm just showing you this again so that we all know. We're going to look at the share editor cap. No, not at all. It's in the share Lua scripts directory, and we have the inject HTTP demo. So here we come back here, and we do with an equal sign. So one of the things that you'll notice is, just like Nmap has the -- script, we have the -- Lua script, and just like Nmap has the -- script args, we have a -- Lua args. So it should be pretty familiar for people who are doing stuff. So let me go ahead and kill this, because we don't really need that anymore. and we'll load up Firefox, and everybody has an awesome intranet page, because intranets are awesome, especially when they're on SharePoint. So anyway, we'll look at this, and it's our OMG intranets with our top secret stuffs here. So what we have here is Metasploit, and so we'll do a jobs here, and like, holy crap, there's a lot of stuff that browser autopwn runs. But the big thing is we're running browser autopwn that you care about, and we're still running the gathering stuff. So over here, we have beef, and everybody loves beef. So what we're gonna do is first we're gonna steal credentials, we're gonna wait a little bit, and then we're going to inject some beef. And after our beef is injected, we're going to pwn somebody. So, okay, everybody ready for this? And like I said, we're not gonna show you the code. Trust me, it's awesome, but there's C in it, so don't worry about that. So let's, yeah, I'm gonna find my VM again. Everybody has like 7 VMs running, right? It's not just me. Oh, I found it again. Oh, but that's not the one I wanted. So we're gonna bring back our Windows client, and as you can see, nothing shows up here. We're going to go back into our here, and we're going to start our ettercap. And one of two things is going to happen. This is either going to work or crash. So I'm hoping for work at this point.
It's not that bad. Come on.
No, I'm just joking.
It crashes when you write the code.
It's mostly true. Anyway, so what we're going to do is we're going to start off by running this. So we see, first of all, that we have captured credentials here. We have captured the credentials here, and we don't see anything here. So before we'd injected the image, so this is transparent. After we wait a couple minutes, we inject a couple more times, and we'll end up waiting to see over here, and we actually bypassed the timer. But anyway, so then we go to our browser autopwn, and so now you can see that stuff is running into browser autopwn. So let's make that a little bit better.
Basically, with the timing, we got it set so it'll rotate the injection scripts every 5 seconds or so.
Which we need for demo purposes. Typically, if you were doing this, you would do a couple minutes between each one, because you want time for beef to be able to do its stuff. But obviously, watching me sit here for 5 minutes and click reload is really fucking boring. So, so let's try this again and make it a little bit happier. So, like I. No, it didn't crash. It's just letting me know that my time's up.
Just, yes.
So anyway, so anyway, we start that back up, and we're going to reload a couple times. So we see here that this is running here. Yeah, that's running now.
They'll believe us if we told them it worked.
Okay, so this freaking worked, and it was awesome, and you're all excited. So we only have 2 minutes left anyway, but so I'm gonna let you talk about this.
Yeah, we really wanted to emulate the. We would love to have the same success that Nmap has seen with NSC. I mean, obviously, layer 2 man-in-the-middle attacks are still a bit of a mystery to many people. That's why they're so successful. But we know that you want to mess with packets. It's easy to write the Luas, and we want to see it happen forever and ever and run off into the sunset holding hands with all of you. But
so if anybody's interested in this and thinks that packet manipulation is cool, come talk to us afterwards, because we have a lot of other stuff that we want to do. So yes. Yeah. So if you're looking for these tools, here's where to find them. Also, Google will tell you both of these answers. So ettercap and can enable. If you want to talk to us, here's our contact info. And this is especially important because the code is sort of half released right now, and it will be finished being released later tonight. So if you can't get to something or don't know where something is, hit us up on Twitter. We'll announce where everything is in probably the next day or two. And then anybody who's interested in working on something, just let us know, and we're happy to work with you on whatever you're interested in. So thanks to all the people who helped us out, and to DerbyCon for having us again, and for you guys for sitting through this. And again, to anybody else who thinks that this is cool and wants to help us out. So, anybody have any questions?
When are you guys going to work on the official Underpants content?
Oh, so you want us to like work on what we're supposed to be working on? It soon.
Today. No, we're happy to. I mean, obviously, Ryan likes being all secretive and stuff, you know. But oh, is that what he calls it? Oh man.
So does anybody else have any questions? That don't involve making me aware of my shortcomings.
Just teasing.
All right. Well, thanks very much.
Thanks, everyone.
Appreciate it.